Hello, Chem Peeps. Today we're going to talk about entropy, which is one of the videos under thermodynamics. Entropy describes the disorder of a reaction. Most things in nature go from an ordered state to a disordered state. And so to calculate entropy, it's going to be the final entropy minus the initial entropy. Again, there are going to be values in your index or in your chapter under thermodynamics for different substances in different states and their entropy value. They are different than your enthalpy value, so be very careful you're in the right column for the right substance in the right state. Basically, when we measure entropy, it's going to be in joules per mole K. And if you get a negative value, you're showing that the reaction is becoming more ordered. And if you have a positive entropy value, the reaction is becoming less ordered. So for example, a sample of water in the gaseous form is going to be less ordered than water in the liquid form. And if we compare that liquid form of water to solid form or ice, ice is going to have more order. So as we go from the solid state of ice to the liquid state of water to the gaseous state of steam, we are becoming less and less ordered. In other words, the molecules are more chaotic, they're more disorganized, they're not in a crystal lattice as we move from the solid state to the gaseous state. Most things in nature tend to spontaneously go from ordered to disorder because it requires less energy. Let's look at the problem set over on the right and solve this problem. I've specifically picked a problem that already had values for the entropies that we needed to use. Again, you can find values for your problems in an index of your book or in the chapter under thermodynamics. So it says, what is the entropy change for a single displacement reaction between table salt and fluoride gas, or fluorine gas? And the delta S values for sodium chloride and fluorine gas and sodium fluoride and chlorine gas are all listed. And they give us a balanced equation. Okay, so we're finding the change. The pen is always goofy. Okay, let's see if we can get this. So the delta S is going to be the products minus the reactants. So in this problem, we're going to have 2NaF minus Cl2, or plus Cl2, sorry, minus the reactants, which are 2 table salts, plus the fluorine gas. Now, one thing I want to state, we have elements here. When we did enthalpy, delta H, elements do not become formed. Therefore, they have a 0 value. But when we're talking about entropy, elements are going to have a value. Okay, so don't get that mixed up. So if we go ahead and substitute in 2 times the sodium fluoride value is 2 times 51.5 plus the chlorine value, which is going to be 223, minus 2 times the sodium chloride value, which is 72.1, plus the fluorine is 20.3. So if we simplify this problem, the delta H of this, or delta S of this reaction is going to be a negative 21 joules per mole K. And it's a little bit different than enthalpy. And since it is negative, a negative value means it's becoming more ordered. Okay, probably not really spontaneous without some changes in maybe temperature or enthalpy. Okay, so let's look at the second problem that we have to solve here. And I am going to erase our first problem just so that I have a little more room. Okay. So in the second problem, it says the entropy change for the decomposition of 1 mole of potassium perchlorate is 494. Calculate the entropy value of oxygen. So we're solving for something inside the equation. And so they gave us the overall, and then they gave us the specifics here. So let's look here. Calculate the entropy value. So we're going to have, if you notice, this has a 2 here, and these values for 1 mole. So I'm going to take the overall times 2, so it's going to be 2 times the 494 that they gave us. So we already have the overall, minus the products, which are going to be 2 KCl plus 3 oxygens minus KClO3. Okay. So, and there are 2 of those. Don't forget that. Okay, so if I substitute in for the reaction products and reactants, I'm going to have 2 times 82.6 plus 3 times X. And I say X because we don't know oxygen. Minus 2 times 143. So if we simplify this equation, I'm going to have 988 equals 165.2 plus 3x minus 286. So 3x comes out to equal 1108.8. So x, which is oxygen, my pen gets a mind of its own, doesn't it? Oxygen is going to come out to be 369.6 joules per mole K. Okay, and so this is entropy calculations. You can find more videos under thermodynamics. My next videos will be Gibbs free energy. Find me on TikTok and YouTube at Kim's Chem Chats.